now we start on parabola. There are two standard forms that we need to remember. The first one will be x squared equals to 4py, and the second one will be y squared equals to 4px. And then this will be the standard graph of the parabola. It either lies on the x-axis or it lies on the y-axis. Then, when we need to find the focus of the parabola, we compare the standard form to the question, and then we will be able to find the focus. After finding the focus, we need to find the directrix. The directrix is normally opposite the focus. So, after finding the focus, we can straight away get to know the directrix. The directrix has the same length as the focus to the point that cuts on the graph. And it is the same for the graph that lies on the y-axis. After finding the focus, the directrix will be directly opposite of the focus and they will have the same distance. So now we move on to the example for parabola. Find the focus and directrix, then sketch a parabola. The question we now have is y squared equals to 12x, and then we compare it to the standard form, which is y squared equals to 4px. By comparing it, we can get 4p equals to 12, and then when we simplify it, it will become p equals to 3. So the question we have is y squared equals to 12x. Thus, the graph will be lying on the y-axis, and then the focus will cut on the x-axis. Since we have found that the focus is equals to 3, and the way we should write the focus is p0. The focus is 3, so the coordinate of focus is 3, 0. And then we know that the directrix is always opposite of the focus. Thus, focus is x equals to p. And so, directrix will be x equals to negative p. P is 3, so the directrix will be x equals to negative 3. And now we need to sketch the parabola. Since we know that the question is y squared equals to 12x, so the graph will be in this way. And then we mark the focus, which is 3, 0. And the directrix is directly opposite of the focus, and we draw one straight line on the x equals to negative 3. So now we move on to ellipse. An ellipse is a set of points in a plane whose distance from two fixed points in a plane have the same constant sum. The two fixed points are the foci of the ellipse. The line through the foci of an ellipse is the ellipse focal axis. The point on the axis halfway between the foci is the center. The points where the focal axis and ellipse cross are the ellipse vertices. So, how do we recognize the ellipse graph? When we see x squared over a squared plus y squared over b squared equals to 1, the x-axis will be the longer one, which means it will be the semi-major axis. Because a squared will always be the larger value and b squared will be the smaller value. So how do we calculate the center of focus distance? We should know the formula, which is c equals to square root of a squared minus b squared. And since x is the semi-major axis, the foci will lie on the x-axis, so we will write it in this way. Foci equals to plus minus c, 0, and the vertices will be the same also, which is plus minus a, 0. The c and a, we can get it from the formula and also the center to focus distance formula. So it same applies to this one. We can see that the graph is long, the line is longer on the y-axis, so the equation will be x squared over b squared plus y squared over a squared equals to 1. So how to find the center of focus of distance? It is the same, which is c equals to square root of a squared minus b squared, and the foci we will write it in this way: 0 plus minus c, and the vertices is 0 plus minus a, because the semi-major axis is only y. So now, let us try on an example for ellipse. The question we have is 16x squared plus 25y squared equals to 400. We know that for every equation, we must make it equals to 1. So in order to make this to 1, we divide everything by 400. And then we will get x squared over 25 plus y squared over 16 equals to 1. So it is obvious that 25 is larger than 16. So the semi-major axis is the x-axis. So a equals to square root of 25 and a equals to 5. While the semi-minor axis is b, which is square root of 16, which then equals to 4. Then we need to find the center to focus distance. The formula we have will be c equals to square root of a squared minus b squared. And we will get square root of 25 minus 16 is equals to square root of 9. Square root of 9 equals to 3. Then foci. Foci is plus minus c, 0. And since we get c is equals to 3, so the foci is plus minus 3, 0. And vertices. Vertices is plus minus a, 0. So since we get a equals to 5 just now, and so we substitute in here, and we'll get plus minus 5, 0. Then we move on to the graph. Since we know that x-axis is a semi-major axis, and we draw the graph like this by marking the point vertices equals to plus minus 5, and the foci is plus minus 3, and then the y, which is the semi-minor axis, is 4 and minus 4, and thus this is the graph of an ellipse.
Now let's move on to the hyperbola. The typical hyperbola curve is either the curves on the left and right side or the curves on the up and down side. A hyperbola is a set of points in a plane where distance is a constant. The points are the foci of the hyperbola. The line through the foci of hyperbola is the focal axis, which is the x-axis for this graph and the y-axis for this graph. The point on the axis halfway between the foci is the hyperbola center, which is the C. The points where the focal axis and hyperbola cross are the vertices. Listen. We differentiate the shape of the graph by the equation. If the equation is x squared minus y squared, the curve is on the left and right side. And if the equation is y squared minus x squared, the curve is on the up and down side. The standard form of the equation of the hyperbola is x squared over a squared minus y squared over b squared equals to 1. Don't forget it's a 1, not other constant. The center to focus distance, which is the c, is square root of a squared plus b squared, where a squared and b squared you can get from the equation. The coordinate of the foci is plus minus c, 0, and the vertices of the graph is plus minus a, 0. To find the asymptotes for the graph, the equation is x squared over a squared minus y squared over b squared equals to 0. When we simplify the equation, we will get y equals to plus minus b over ax. For this graph, the standard equation is y squared over a squared minus x squared over b squared equals to 1. Then the center to focus distance is same as just now, which is c equals to square root of a squared plus b squared. The focus is in the other way around, which the coordinate is 0 and plus minus c. The vertices is also the other way around from just now, which the coordinate is 0 and plus minus a. The asymptotes is y squared over a squared minus x squared over b squared equals to 0. We simplify the equation and we will get y equals to plus minus a over bx. Now let's try on one example. Write the following equation in standard form and find the hyperbola asymptotes. Then sketch the hyperbola. The equation we are going to use is 9x squared minus 16y squared equals to 144. In order to write it in the standard form equation, we divide the equation by 144, which is x squared over 16 minus y squared over 9 equals to 1. To find the center to focus distance, which is c, we use the formula of square root a square plus b square, where a square is 16 and b square is 9. So square root of 16 plus 9 is 5. To find the asymptotes, we use the formula of y equals to plus minus b over ax. B square is 9, so b equals to 3, and a square is 16, so a equals to 4. So the asymptote is y equals to plus minus 3 over 4x. We then sketch the graph. Since the equation is x squared minus y squared, the curve will be on the left and right side of the graph. From the calculation just now, we get the center to focus distance is 5, so we label 5, and the asymptote is y equals to 3 over 4x is represented by the dotted lines.